Let Z be a standard normal random variable. Use the calculator provided to determine the value of C such that P of Z is less than or equal to C is 0.7881. So since 0.7881 is bigger than 50%, I know that if I'm going to have a C score that has a value that's bigger than 50%, and that's everything to the left, so that's Z less than or equal to is to the left, let's go out to Word and capture that. So I'm going to go out here to shapes and try to draw a bell-shaped curve, get rid of the laugh. It's not bad, huh? Freehand. All right, it's not very symmetric though. All right, so there's our bell-shaped curve, and I want everything to the left of that to equal 0.7. So 0.7 is bigger than 5. So I know everything to the left to the halfway point is 0.5. So then in order for it to be 0.7, it has to be even further to the right. So maybe about right here. All right, and that means everything shaded to the left would be, I'm trying to see if there's a little paint guy. There's no paint, huh? I guess I have to open the paint program. I want to shade the region. I guess I could do little squiggles like this. Yeah, that's it. So it's everything to the left over here. Oh, shoot. Kind of went above the curve, but you got the idea. You got the idea. So that area to the left needs to equal needs to equal 0.7851 or whatever that value was. And so I need to know the area to the right in order to do the Z box. So I'm just going to go out there and grab that. So I'm going to go 1 minus 0.7881, and that'll give me the area to the right, which is 0.2119, and then I'll just find the Z score for that. And you get 0.7998. All right. About that, my previous recorded popped on once it finished producing. So here we have the genders of 3 children of a certain family, soon to be revealed, and outcomes are thus triples of girls and boys. And we write GBG and BBB, etc. for each outcome. So here we have the outcomes of the triples. And then we have R standing for, I believe, the number of boys. Yeah. Oh, actually, R stands for girls here. So R is the number of girls because we have 2 girls and the random variable is 2. And then we also substituted into this equation for the random variable X. So here are the numbers generated below. Let me move over the screen so you can see all of the table. There you go. And so they ask us to calculate the probability for X. So we're going to take a look at the values. We can see that there's a -3, a -4, a 0. I think that captures all of them. So the -3 occurs 1, 2, 3, 4 times. So 4 out of 8 possibilities, so 1/2. So 1 divided by 4, 4 divided by 8 is 1/2. The -4 occurs 3 times, so that's going to be 3/4. How about 3/8? All right? And then this one here occurs once, and it's 1/8. And sure enough, if you add up all the probabilities, 3/8 and 1/8 is 4/8, or 1/2. And 1/2 and 1/2 is 1. So they do add up to 1. So let's go on to the next question. All right, we have a manufacturer of fertilizer guarantees that with the aid of fertilizer, 80% of the plant seeds will germinate. And suppose the manufacturer is correct on this 80% germination rate. If 10 seeds planted with the fertilizer are randomly selected, what's the probability that more than 8 will germinate? So we know that the probability of them germinating 1 seed I am so sorry, you guys. Is 80%. We've got 10 seeds and we want more than 8. So I'm going to write down P equals equals 80%. We can write that as 0.8. And then N is equal to, it's capitalizing everything. is equal to, I think there were 10 seeds. I better go back out there and check that out. And then X was more than 8. Let me just make sure that I captured that right. Yep, 10 seeds, and then more than 8 of them germinate. All right, so more than 8 would mean that X equals 9 or 10. And if you were to look at all the possibilities of how many seeds could germinate, you can kind of like put them like in a little set notation. So I'll go out to math type and capture that. So if you were looking at all the possible cases, X would take on 0 seeds germinate, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And so that would capture all the possibilities of what X could actually take on. Well, we're going to cross out, if you can think of that, as getting rid of the 9 and 10. So that means everything from 0 to 8. And you say, well, why are you going backwards? Well, it turns out the ALEKS calculator will compute the cumulative probabilities if you start at 0. Or you could do that probability for 9 and the probability for 10 and add them up. But we're going to use that nice button on the ALEKS calculator that does cumulative probabilities when you start at X equals to 0. So it turns out to find the probability that X is more than 8, that's equal to that's equal to 1 minus the probability that X equals 0, 1, 2, all the way up to 8. And so we're just going to use that on the ALEKS calculator. So let's go out there and do that. All right. So it's going to be 1 minus, and I'm going to hit the probability of B key. N is equal to 9, excuse me, 10. The probability of them one seed germinating is 0.80. All right. And then, and we want this to be 8. So it turns out this top number is always the maximum value when you start at 0. And so if we go back out to Word, we can see that the max was 8 when we started at 0. All right, and so we'll compute that, and we get 0.375, and they tell us to compute this one to at least 2 decimal places. So 0.37. Oh, no, 0.38, huh? 0.38. All right. Oh, I think I hit the wrong button. I can't see the key because the little controls for the screen capture guy. Let me see the keys. All right. So here for recent evening of small old-fashioned theater, 30% of the moviegoers are females, while 2 moviegoers for 2 movies were playing that movie. One was a romantic comedy and one was a World War II film. As might be expected, the females, among the females, the romantic comedy was popular, and with the male moviegoers were romantic comedy also. Among the male moviegoers, the romantic comedy also was more popular. Never mind. I don't know if I read it wrong or what. Oh yeah. Okay. Sorry. The teacher's crazy. All right. Okay. So they like movies. They like the romantic comedies too, but 50% compared to 80%. All right. So fill in the probability for the tree diagram below. So since this one here is for the war film, is 0.7, not the war film is going to be 0.3 because they have to add up to 1 because they're disjoint sets or mutually exclusive sets. You're either going to do one and not the other. And you know that by that bar, it's the complement. And then similarly here, 0.8 here, which means that this would have to be a 0.2. And here, since this is 0.5, this one would have to be 0.5. And then in order to get the probability for Anne, both a female and like the romantic comedy, then it turns out it would be 0.3 times 0.8. And 8 times 3 is 0.24. And so you get 0.24 for this one. And then 0.3 times 0.2 is 0.06. And then 0.7 times 0.5 is 0.35. And then 0.5 times 0.5, oh again, it's going to be the same answer because it's both 0.5. So then we'll just check to make sure it adds up. So 35 and 35 is 70, and then 24 and 6 is 30. 30 and 70 is 1. So it adds up to 1. What's the probability that a randomly selected chosen moviegoer attended the war film? And so the war film is going to be not the romantic comedy. So that's going to be the ones with the R bars. So the war films are the R bars. So the complement to the romantic comedy. So this is an R bar and this is an R bar. So these two probabilities I want to include. That means they were male and they liked the war movie, and they were female and they liked the war movie. So 0.06 and 0.35, when you add those up, is 0.41. All right, so then let's go to the next problem. Events A and B are mutually exclusive. Suppose that event A occurs with a probability of 0.18 and event B occurs with a probability of 0.66. Compute the probability that A does not occur or B does not occur or both. Okay, so so let's do a little Venn diagram to capture that. Alright, so I've managed to draw a Venn diagram using Word showing A and B. Notice these two sets don't overlap because they're mutually exclusive. And so the first thing they ask us to find in this problem is compute the probability that A does not occur or B does not occur or both. So A does not occur means everything outside of A. So if I were to, that's a format painter. I got a little excited. Well, I'll try to draw it. So this is not A. So it's everything outside of A. Okay? So that would be it. So everything outside of A. So it could include B. Then the other one says everything outside of B. Or everything outside of B. So if everything outside of B, wouldn't that include the A? Oh no, what did I just do? How about Control Z? Okay. Oh no, I don't know what I just did. Anyway. Alright, cool, that's better. I was just trying to change the tool and change the color of the tool. But maybe I can't do that from here. Anywho, I was going to try to make it red, but that did something so strange. Oh, that changed the last one. Okay, cool. Alright, so I'll make a new one. Alright, here we go. Alright, so now we're going to do everything outside of B. Alright, so that's everything outside of B. So if it's outside of B, that includes A, doesn't it? Just doesn't include the B. So that's a 2. Okay. And then now I'm going to change the color or the shape. shape. I'm going to change it to this color. Hey, there we go. I figured it out. So you can see, once you put the red and the black together, it's everything. One or the other or both is everything. So the probability of the whole set is just going to be 1. Alright, compute the probability that either A occurs without B. So let's do that first. So A occurs without B. So that's A and B bar. Okay, A and B bar. So let's go back out to our beautiful diagram. Alright, so now we're going to do A and B bar. So A is going to be everything inside of A. So it's going to be in here. Now you can see I'm having so much fun. Oh my goodness, I went outside the circles. Don't tell anybody. So that's A. And then intersect everything outside of B. So now I'm going to draw it again. So I'll click the little tool again. And then I'm going to draw everything outside of B. And you can see, oh, then you know what? That's going to also include A. And I want the overlap of that. So let me go ahead and change that second color. So I want to know where the red and the black overlap. And you can see, oh, the red and the black, they overlap inside here of A. So remember, A intersect B bar is always A. So let's capture that. I'm using math type. So A, and there's actually an intersect button. Here you go. So A intersect B, and that's B bar. So let's give this one a little hat. Will always equal A. Similarly, B intersect A bar. What do you think that guy's going to be? Yep, it's going to be B. All right? Okay. So let's go back out to the problem. I don't know if they asked for the second creature, but just a general rule to know. All right. So probability that A occurs without B, that's the same as just saying A. Or B occurs without A, that's the same as just saying B. So it's just saying A or B. Since they're mutually exclusive, you just add up the probabilities. And so they tell us that the probability of A is 0.18, B is 0.66. So since they're mutually exclusive, we just add the two together. So we add the 0.18 plus 0.66. Okay, let's make that a point. All right, and we get 0.84. So I hit Control C and copied it, and I'm going to put that here. All right, we'll stop here, and I've got to question 10, and I'll do the last 6 on the next movie.